We're ready now to cover the section on electric potential energy and electric potential. For reference, this is chapter 25 from Knight and chapter 23 from Young and Friedman. Some of the background I assume you're familiar with from 1051 is on this slide. We know that charges will feel a force when they're placed in an electric field. That's something we've already covered. We know that an electric force is a conservative force, and therefore you can write a potential energy function to be associated with that electric force. We know that the change in potential energy is the negative of the work done by a conservative force. And we also know that the work done by a conservative force is the integral of that force over the distance which it's applied. If you put in that your force is charge times electric field, then you can come up with the expression for the change in potential energy, electric potential energy. I expect you've gone through this process for constant electric fields, such as those between the plates of a capacitor and between point charges. Something good to know is that if you release a charge from rest, it will move towards an area with lower potential energy. That comes from the fact that force is negative the derivative of potential with respect to distance. That's the same motion that you get with gravity. If you have a car on top of a hill, it will roll down to the bottom. If you have a mass on a spring, it will go back towards equilibrium. Same deal is true with electric fields. If you release a charge from rest, it will move to an area with lower potential energy. Next, we get to electric potential. Electric potential has some different names. There's electric potential, there's plain potential, there's potential difference, there's electric potential difference, and then there's plain old voltage. That has a symbol of V in units of volts. Electric potential is related to electric potential energy, similarly to how electric field and electric force are related. The electric field tells a charge Q what force to feel if it's placed in an electric field. We know that the expression is that the force is charge times the electric field. If we place a charge Q in an electric field E, it will experience force F. Alternatively, you could say that the electric field is the electric force per unit charge. So those are some ways you can discuss field and force. Likewise is true with electric potential and electric potential energy. The electric potential tells a charge Q how much electric potential energy to have. If you place a charge Q in a region with electric potential V, it will have an amount of energy U equal to Q times V. You could also say that electric potential is the electric potential energy per unit charge. Since potential energy is related to field and electric potential is related to electric potential energy, then the electric potential is related to the electric field. And we know that that expression is that electric potential is the negative of the integral of the electric field over the distance where we have the electric field where the charge is moving through. What else do we have to say here? Last is conservation of mechanical energy. So like all systems, mechanical energy is conserved in systems with fields and charge as long as there are no non-conservative forces like friction. So mechanical energy is kinetic plus potential. Kinetic energy, we'll use a symbol of K, that's a half mv squared, it's the energy of motion. We use U for potential energy, and we'll often put an E on it to symbolize electric potential energy. We can use this conservation of energy to solve lots of problems. Some of those problems are listed in the review questions, and I'll do at least one example to post with our class notes. This is a list of the set of kappa questions that goes with this area. I expect if you're familiar with this topic from Physics 1051, you could probably just jump in straight ahead and get these problems done. If you try them and you're having a little bit of trouble, then I would say try again as we're going through the material.